All right, today we are diving into a really wild frontier in AI. We're talking about a technology where a simple line of text doesn't just describe a world, it actually builds it. An AI that can generate entire interactive universes from just a few words. Let's see how this whole thing works.
So have a look at this. This isn't just a sentence, it's a prompt. It's basically an order for an AI to create a photorealistic, interactive world from scratch. And the key word there is interactive. The water isn't just a video, it actually flows, it reacts, it behaves like you'd expect real water to. This is a full-on simulation.
And it's not just stuck making realistic nature scenes, not at all. This prompt generates a whole city made of ice that you can move around in real time. I mean, this is a huge leap past just generating a pretty static picture.
And here's the best part. These worlds aren't just for looking at, they are fully interactive sandboxes. This prompt, for example, creates a playable character. Yep, a cardboard box that actually follows the rules of physics. It's got weight, it can jump, and it can actually shove things with kinetic force. This is true simulation, not just some pre-canned animation.
This stuff is just incredible, right? But how? How does an AI learn not just what a world looks like, but the physics and the rules that actually make it tick?
Well, the core idea behind all this magic is actually surprisingly old. It's a concept that's been around for decades, but we've only just now gotten the technology to actually build it at this kind of scale.
It's called a world model. And unlike the other AIs you're probably used to hearing about, a world model is specifically built to learn the dynamics of a place. It's designed to constantly ask and answer one simple question. Okay, if I do this, what happens next?
You know, a really great way to get your head around this comes from Quantum Magazine. They said to think of it like a computational snow globe. It's this tiny, self-contained version of reality that the AI holds in its mind. It can shake it up, run experiments, and learn how things work, all safely inside its own simulation, before ever trying something in the real world.
And what's really wild is that this idea isn't new at all. A psychologist named Kenneth Craik came up with this all the way back in 1943. He argued that our own brains do this. We build these little, small-scale models to safely test out different choices before we actually make them.
So you might be thinking, okay, but how is this really different from the AI I use every day, like ChatGPT? And understanding that difference, well, that's the key to seeing why this is a whole different kind of intelligence.
It all boils down to their main goal. A large language model, an LLM, is a master of language. Its job is to predict the next most likely word in a sentence. But a world model? Its job is to predict the next state of an entire environment. It's all about cause and effect in a simulated world.
Let's make this super concrete. If you ask an LLM what happens when you push a box, it'll describe it. It'll just write out the words, the box slides across the floor. But a world model will actually simulate it. It'll render the box moving, calculating stuff like friction and momentum. One of them tells, the other one shows.
This difference really comes down to how they learn. LLMs often work using what researchers call bags of heuristics. Think of it like a big bag of disconnected rules of thumb. They work in specific situations, but they don't add up to a consistent picture of reality. A world model, on the other hand, has to build a coherent, interlocking machine of understanding, because if one rule is wrong, the whole simulation just falls apart. So, as we've hinted, this idea has some deep roots. Let's just take a quick trip through its history, from a psychological theory to what we're seeing today.
So after Craik's big idea in the 40s, people tried to build these models by hand, but they were just too brittle. By the 80s, a lot of roboticists just gave up and said, forget it, the world is its own best model. Let's just have robots react to things directly. But now, the sheer power of deep learning has changed the game, allowing an AI to finally learn these complex models all on its own. It's bringing Craig's original vision roaring back to life.
So, with this powerful idea finally reborn, what's next? Where is this whole quest for a simulated reality actually taking us?
Well, the potential here goes way, way beyond just making cooler video games. I mean, imagine training self-driving cars in millions of perfectly simulated, totally safe scenarios. Or what about students getting to literally walk through ancient Rome for a history class? It's an unbelievably powerful tool for training any kind of robot or AI to deal with a complex world.
But okay, let's be real. We are not quite there yet. The technology still has some pretty big limitations. These simulations can only stay consistent for a few minutes at a time. They have a hard time with lots of independent characters doing their own thing. And they definitely can't perfectly copy a real-world location. Yet. there's still a long way to go.
But as researchers start to knock down these barriers, one by one, it leads to this final, pretty profound question. The whole point of a world model is to create an AI that can truly understand and predict our reality. So if an AI actually achieves that, if it can run countless experiments inside its own little snow globe, what will it conclude is the best thing to do? What might it decide needs to be changed? That is something to think about.